Hi, I'm Matt, and this is my personal reflection video for the Deco7385 project. Our project is called Racing Coffee Table. It's a coffee table you can actually play with. We have another players and 2 cars. We designed it to make office break times more fun and interactive. And I asked myself, what if an ordinary table could turn into a playful game space? I was mainly responsible for the car control system, circuit writing, and mechanism development, and part of the exhibition setup. We created a mini-maze track with racing cars, physical obstacles, and interactive mechanisms. We have 2 control methods. One is to fix the sensor on the body with a bag and control it by body's high angle. The other is for the player to hold the ball in his hands and control it with the ball. Then the car will move. At the beginning of the project, I participated in the design of the maze paths and the mechanisms. This is our low model, a paper maze and 3 mechanisms, which we simulated with a wooden car. At the beginning, the car will start at the position and through the 3 mechanisms. The first one is the electric rotating. The second one is the X door. Then our car will pass these 2 mechanisms and go to the last one, the elevator-like mechanism. I was responsible for over 70% of the maze construction, including circle design, soldering, structure assemble, and metal processing. At the beginning of the project, I defined the car's control logic and began hardware testing using ESP32S3 board. First, I used a classical L298N bridge motor driver model. It allows control of 2 DC motors for forward and reserve motion, one of the core components of our car system. After hard work and coding, finally, 2 motors works very well. Then we install it at the deep of the maze. I studied how resistors function and learned the resistance value using color bands. For the security, I designed the full logic system to control the car's movement in all directions. Our car is controlled by the remote at first. Then we change it. I also looked into how transistors work, learning about the pin codification, switching behavior, and how they are used for low-level control. During testing, I manually selected soldered resistors with difficult values to ensure they match the logic needed for our car control system. For me, this process is not just writing. It's a hands-on way to reinforce my understanding of electronics fundamentals. I also prepared to integrate an MPU6050 accelerometer motor sensor for gesture-based control. Also, it wasn't finalized. I conducted related tests. To achieve stable and reliable car control, I tested several difficult hardware models. At the beginning of the project, I tested 2 different development boards, the Circle Playground Classicals and the Circle Playground Express. They look similar both with the circle design and ideal for rapidly interactive prototyping. The Classical is suitable for simple tasks. The Express version is suitable for our tasks. After comparing with the performance, I decided to use Circle Playground Express as the main controller for the car. Then our car moved very well. The onboard features allowed us to memorize external models, saving a lot of writing and debugging time. In the final system, this board handled all the directional controller and activation logic for the car. It became one of the most important parts of our project. This project helped me truly understand the challenges and joys of combining hardware and software in interaction design.